Take note, key concept, roots, zeros, and x-intercepts. The following are equivalent statements about a real number b and a polynomial p of x, which equals a sub n times x to the nth power plus a sub n minus 1 times x to the n minus 1 power plus, the pattern continues, plus a sub 1 times x plus a sub 0, a constant. X minus b is a linear factor of the polynomial p of x. B is a zero of the polynomial function y equals p of x. B is a root, or solution, of the polynomial equation p of x equals 0. And b is an x-intercept of the graph of y equals p of x. Problem 2. Finding zeros of a polynomial function. What are the zeros of y equals the binomial x plus 2 times the binomial x minus 1 times the binomial x minus 3? Graph the function. First, consider what you know. You know a polynomial function, written in a factored form. Then consider what you need. You need the zeros, you need some additional points, and you need the end behavior. And so your plan, use the zero product property to find zeros. Find some points between the zeros, and sketch the graph. Step 1. Use the zero product property to find the zeros. We can set each of the binomials equal to 0 and employ the zero product property. So, x minus 2 equals 0, or x minus 1 equals 0, or x minus 3 equals 0. The zeros of the function are, the x values that satisfy each of these equations, -2, 1, and 3. Step 2. We'll find points for x values between the zeros. So we'll evaluate our original function y equals x plus 2 times x minus 1 times x minus 3 for values x equals -1, x equals 0, and x equals 2. When x equals -1, we substitute -1 for x in the function and find that when x is -1, y is 8. Substituting 0 leads us to the point 0, 6, and substituting 2 leads to the point 2, -4. Step 3, determine the end behavior. The function y equals the binomial x plus 2 times the binomial x minus 1 times the binomial x minus 3 is cubic. The coefficient of x cubed is +1, so the end behavior is down and up. Step 4. We'll use the information gathered thus far. The zeros at the points -2, 0, 1, 0, and 3, 0. The additional points that we computed, -1, 8, 0, 6, and 2, -4, and the end behavior that we found to sketch the graph. Plotting the points, noting the end behavior, and connecting the points with smooth curves, and of course adding arrows at the ends. Your turn. What are the zeros of y equals x times the binomial x minus 3 times the binomial x plus 5? Graph the function.